PH7 2197 A66A6 CACML B6. The topic is demonstrate selection sorts a heap sort. Selection sort. Selection sort. In this algorithm, we select the smallest element from an unsorted array. Unsorted array in each pass and swap with the beginning of the unsorted array. This process will continue until all the elements are placed at right place. It is simple and an in-place comparison sorting algorithm. Means it is an in-place comparison sorting algorithm. Here, here, first step will take 2, 4, 1, 3, 5. Swapping of 2 to 1. 1 gets sorted and in the order it will come 1, 2, 4, 3, 5. Okay. And next, second step is 1, 4, 2, 3, 5. And when we sort, 2 will come front 1, 2, 4, 3, 5. This is swapping and this is sorted. And 1, 2, 3, 5, 1, 2, 4, 3, 5. Here it is swapped 3, 4, 5. And the final step 1, 2, 3, 4, 5. No swapping required. 1, 2, 3, 4, 5. This is the swapping and sorting between the five number of elements. Working of a selection sort. The following are the steps to explain the working of the selection sort in Python. Let's take the unsorted array to apply the selection algorithm. 2, 4, 1, 3, 5. Get the length. Get the length. The length is equal to length of array. And the second step is first we set the first element of the minimum element. Means we'll take the first set of the minimum element. Here the minimum element is 1. So we'll take the first step as 1. Step 3. Now to compare the minimum with the second element. If the second element is smaller than the first, we assign it as a minimum. Again, we compare the second element to the third, and if the third element is smaller than the second, assign it as an minimum. The process goes on until we have find the last element. After each iteration, the minimum element is swapped in front of unsorted array. The fifth step is the second of the 3 steps are repeated until we get the sorted array. Until we get the sorted array. Selection sort algorithm. Repeat 0 of 0 comma length -1 times. Set the first unsorted element as the minimum for each of unsorted elements. If element is less than the current minimum, set element as new minimum. Swap minimum with first unsorted position. This is the selection sort algorithm. Selection sort. Sorry. Def selection sort of array. Length is equal to length of array. For I in range of length minus 1, minimum index is equal to 1. For j in range of I plus 1, comma length if array of j is less than minimum index. Minimum index is equal to j. Array of j, comma array of minimum index is equal to array of minimum index, comma array of j. Hence, here we can see that the first they have took two two what two for loops. So first for loop is for I in range. Second for loop is for j in range. Okay. For I in range, length minus 1. For j in range, I plus 1, comma length. Array of I, comma, array of minimum index. Array is equal to minimum array of minimum index, comma array of I. Return array. Array is equal to 21, comma 6, comma 33, comma 3. Print of the sorted array is selection sort of array. Is selection sort of array. Output. The sorted array is 3, 6, 9, 21, 33. Explanation. First, we define the selection sort. Function that takes array as an argument. In the function, we get the length of array which used to determine the number of passes to be made comparing values. As we can see that we use two loops, outer and inner loop. The outer loop uses to iterate the values of the list. The loop will iterate to 0 to length minus 1. So the first iteration will be performed 5 minus 1 or 4 times. In each iteration, the value of the variable I is assigned to the variable. The inner loop uses to compare the each value of right side element to the other value on the leftmost element. Each right side element to the other value of leftmost element. So the second loop starts its iteration from I plus 1. It will only pick the value that is unsorted. That is unsorted. Find the minimum element in the unsorted list and update the minimum index position. Place the value at the beginning of the array. Once the iteration is completed, the sorted array is returned. At last, we create an unsorted array and pass the selection sort. It prints the sorted array. Time complexity of selection sort. Time complexity is an essential in the terms of how much time an algorithm takes to sort it in the selection sort. In the selection sort, there are many types. There are two loops. The outer loops run for the n times. N is a total number of elements. The inner loop is also executed n times. It compares the rest of the value to the outer loop value. So there is n times of execution. Hence the time complexity of merge sort algorithm is O of n2. The time complexity can be categorized in three categories. Heap sort. Heap is nothing but is a type of a data structure that is based on trees. A priority queue is represented by an heap data structure. A binary tree is said to be follow an heap data structure. If all nodes in the tree are greater than the children in the tree, it will be a complete binary tree. There are two heaps. One is maximum heap when each parent node is less than or equal to child nodes. Minimum heap when each parent node is greater than or equal to child nodes. Child nodes, right? Okay. Minimum heap one, 2, 3, 6, 5, 4. Here 2 has 4, 6. Here 3 has 5. Yes, 4 has 1. This is minimum heap. This is maximum heap. Heap sorting working. The heap sort is similar to selection sort in that we locate the maximum element first and then place it at the end. But in heap sort, we repeat the same process for the remaining elements. It follows three main steps, which are as follows. Swap. It removes the root element from the array and places it at the nth position. Place the tree's last item heap in the empty spot. Remove the size of the heap is reduced by 1. Heapify. Heapify. It uses recursion heapify root element once more such that the highest element is at the root. Algorithm. Define an function heapify. Pass three parameters A and B. Find the largest among the root and child. If the root is not the largest, swap it between with children. Continue to heapify. Define function keep short. Pass array as a parameter and build max heap and swap. Heapify the root element. The result will be the sorted array. Print the result. Program for heap sort. Def heapify of array a comma b. Largest is equal to b. L is equal to 2 into b plus 1. Root is equal to 2 into b plus 2. If length is less than a and array of b is less than array of length, largest is equal to L. If root is less than a and array largest is less than array of root largest is equal to root. If Largest not equals to b, array of b comma array of largest is equal to array of largest comma array of b. This is the sort an array of a given size, and this is the driver code. Output: the original array is 72563 184, and the array after sorting is 1 2 3 4 5 6 7 8. The time complexity, the best case complexity. It occurs there is no sorting required. That is, the array is already sorted. The best case time complexity of heap sort is O of n log n. Average case complexity, it occurs when the array elements are in jumbled order, that is, not properly ascending and not properly descending. The average case complexity of heap sort is O of n log n. The worst case complexity, it occurs when the array elements are required to be sorted in reverse order. Reverse order. Space complexity, the time complexity of heap sort is O of n log n in all three cases: best case, average case, and worst case. The space complexity of heap sort is 0 of n. And thank you. And wait a second. Here there is a heap sort an array of a given size. I forgot to say this. If A is equal to length of array for B in range A by 2 minus 1 comma minus 1 comma minus 1, typify array A comma B for B in range A minus 1 comma 0 comma minus 1, array of B comma array of O, array of 0 comma array of B, typify array comma B comma O. Driver code is array is equal to 72563 184. Print the original array is array. If sort array A is equal to length of array. Print array after sorting is array. And thank you.